Let's take a look at this example. Okay, so let's look at the currents. Okay, this is 0.05 amps, which is simply 50 milliamps, and this one is 0.017 amps, which is equal to 17 milliamps. Okay, because we can have difficulties to see what values are they. So we have to find resistance R1. Okay, we have to find the resistance R1. So in order to do so, basically what we're going to do, we have to find the voltage, okay, because resistance is equal voltage over current, right? We have given current already. So what I would do, I would simply find the total resistance of these two resistors first. Okay, so let me do it. R2 is equal R2 times R3 over R2 plus R3. The question is why I'm using this formula, because I have just two resistors which are in parallel. Okay, in parallel because the current is going to flow through these two resistors, is going to split, and at the other end is going to come back together. So it means that these two resistors are in parallel. So R23 is equal R2 2.2 kilo ohms times 4.7 kilo ohms over 2.2 kilo ohms plus 4.7 kilo ohms. This is equal 2.2 exponent 3 times 4.7 exponent 3 equals, divide by open parenthesis, 2.2 exponent 3 plus 4.7 exponent 3 close parenthesis. This is equal 1.49. I can say 1.5 kilo ohms. 1.5 kilo ohms. Okay, so let's take a look what we did over here. So I can redraw the circuit right now, and the circuit is going to look like this. We have a voltage source, we have resistor R1, okay, and we have resistor over here R2, 3. We got two resistors which are in parallel. Parallel because the total current is going to split into two currents, and these two currents are going to make I total again at the other end. So it means that these two resistors are in parallel. In other words, these two resistors are connected together by two terminals. Okay, if the resistors are connected by two terminals with each other, it means that these resistors are in parallel. So we found this resistance. Now keep in mind that we have given this current. This is my IR1, which is equal 17 milliamps. Okay, we have also given I total, which is equal 50 milliamps. Now KCL says in this case that I total is equal IR1 plus IR2 3. I need to find the current which goes through this resistor, okay, this equivalent resistor for these two resistors. Okay, let me just remind you that this resistance represents these two resistors. Simply you can replace these two resistors by this resistor. So I have to find this current. In order to find this current, I have to move IR1 to the other side. So I have I total minus IR1 is equal IR2 3. Okay, so I can say that IR23 is equal I total, which is equal 50 milliamps minus 17 milliamps, because this is the value of my current IR1. So again, practice the calculator. We have 50 exponent 3 negative minus 17 exponent 3 negative, okay? So I have 33 milliamps. Okay, when we have 33 milliamps going through the resistor R23, we have to simply find the resistance, okay? Resistance, but someone is going to say, but what about the voltage? Okay, keep in mind that in parallel circuit, let me repeat myself one more time, voltage source, which is V1, is equal to VR1, this is also equal to VR2, this is also equal to VR3, and this is also equal to VR23. Okay, so now we can find the voltage total, okay, because we know the current which goes through the resistor R23, and we have resistance of resistor R23, so we can find the voltage. So voltage R23, which is also equal to voltage of resistor R1, cross resistor R1, and this is equal IR23 times R23. IR23 is equal to 33 milliamps times resistance R23, which is equal, resistance R23 is equal 1.5 kilo ohms. Okay, we found it over here. Okay, so VR23 is equal, we have 33 exponent 3 negative times 1.5 exponent 3. This is equal 49.5 volts. This is 49.5 volts. So this is the voltage of my source. This is voltage across each resistor simply. Okay, so we found the voltage across resistor R1. If I have the current, I can find the resistance of this resistor. So R1 is equal VR1 over IR1. VR1 is equal 49.5 volts divided by IR1, which is equal 17 milliamps. Okay, so we have 49.5 divided by 17 exponent 3 negative equals 2.91 kilo ohms. 2.91 kilo ohms. Okay, so we found the value of the missing resistor. Okay, and we can say that the problem is solved.